This is lesson 9.2 about more functions. There is a typo on this front page. We'll talk about it. It's number 1D. So if you got one of the original worksheets, make sure your function on number D looks like this. The original typo had this guy as a minus sign. I apologize for that. So make sure that D has +1 at the end to fix that issue. All right, let's start with number 1A. We just need to state the domain and range of this. This function, we already have a picture of it. Domain, remember, is all of the x values that this graph will show or eventually show. This parabola has arrows on it. Therefore, I believe that this parabola will continue to extend up and to the left, as well as extend up and to the right forever. If you imagine this parabola growing, it's going to continue to grow both directions, left and right. Domain is asking us, does it ever stop going to the left and does it ever stop going to the right? Since the answer to that question is no, it doesn't stop, we're going to say that the domain is all real numbers. Another way to state the domain is to say that x is in between -infinity and +infinity. Whichever way you like to say it, it doesn't matter to me, but know that this graph will never stop getting fatter or wider. It'll keep going to the left and to the right. The range is the numbers in which this graph shows in the y direction. So, does this graph ever stop going up or down? Is there ever a portion of the graph where it's not shown in the y direction? If you notice, this graph stops going down at this point. There is no graph down here. There is graph only above this y value of 2. So to say that, we say that the range is all values y such that it's greater than or equal to 2. It can be 2 or anything above. It could be 3, it could be 4, it could be 5 because it's anything above the value 2. Part B is the same kind of question, and again we have a parabola with a picture. Does it move left? Does it move right? Does it ever stop moving left or right? No, it doesn't, so I would say that the domain is all real numbers. For my range, it does stop moving up and down. It does go up and up and up and up, and it will never stop moving up, signified by those arrows. However, it does not go down forever. It bottoms out. And where does it bottom out? What y value is the bottom of this graph? The y value is at 0. So y is always greater than or bigger than 0. It's bigger than 0. These y values up here is where the graph or the picture is. Part C, this is a linear equation. If you think about the graph of this, it's going to cross the y-axis at -10, and then it's going to have a positive 2/1 slope. So something like this. You can kind of imagine what that graph is going to look like. Any line always has arrows at the end. So if you notice, the graph is going to continue to go to the left, continue to go to the right, continue to go up, and continue to go down. So I would say both the domain and the range are both all real numbers. Okay, and then for part D, again, we already talked about that typo. Make sure your part D looks like this. And then basically this is going to be a quadratic. We don't have a picture of this, but I know that quadratics in this class always look like this or like this. In future math classes, they might look different, but in this class, they either are facing up or they're facing down. In fact, this parabola, I could tell you right now, is facing up because that x squared is positive. So it's going to look something like this. Let's talk about the domain and range of this in general. Domain is how far it goes left and right. Well, this parabola is going to continue to grow fatter and taller as he extends. So that means he's going to have a domain of all real numbers because he never stops moving to the left and he never stops moving to the right. Now the range is a different situation. The range is how far this guy moves up or down. I can clearly see that this one has a bottom. I'm not sure how far or where that that parabola bottoms out, but there is a lowest point or a minimum. And that minimum point or that lowest point would have to be its vertex. If we can figure out the vertex of this parabola, we would know that y has to be greater than that number, somewhere above that lowest point. So we know that y has to be greater than or equal to something. In other words, the y value of the vertex. To find the vertex, we know we can first solve this graph for the x-intercepts and then go from there. So we have 3 ways to solve for x-intercepts now. We can factor this guy, we can quadratic formula this guy, or we could complete the square. I think I am going to factor him. I just like factoring the best. So I'm going to plug in x squared, my first term and my last term, directly into my box. I'll multiply those 2 numbers together for the top number of my diamond and steal the middle number for the bottom number of my diamond. I ask myself what multiplies to 1 but adds to -2. Well, I know that 1 times 1 is 1, but if I make those both negative, they would add to -2 and still multiply to +1. I'll put those in my box like this, -1x and -1x, and then factor it. X, -1, -1. Okay, this guy factors 2. X minus 1 times x minus 1. So what are the zeros? Oh, interesting. We have a double root going on. X must equal 1 in both cases. If I think about what that parabola is, he equals 1, so it's right here and only right here. That parabola only just barely touches the x-axis and goes back up. Remember, we know he goes up because the x squared piece is positive. So it must look like that. What then would be the bottommost point or the bottommost y value? That must be 0. You can see now that he's right on the x-axis, so it crosses right there. So the lowest y value, looking here, is 0. For the next page, we're going to do some continuation of some function notation. So let's look at number 2. We're going to plug 5 into the function h. That means we're going to take h, plug in 5. So for every x we see, we're going to instead write a 5. And then we just need to simplify. Looks like I have 10 plus 1, so altogether I have 11. Make sure to include your function notation so this answer makes sense. When I have the function h, I plug in 5, I got 11. Number 3, the same situation. We're going to take the h and we're going to plug in -7 for all of those n's. So instead of saying n, we're going to say -7. I like to always substitute with using parentheses. That helps because then I know what I need to square and what I don't. Here, for instance, I need to take -7 and square it. Well, -7 times -7 is positive 49. I'll then times that by 2 on the next step. Over here, in the meantime, I get -21. And then I can do 2 times 49, which is 98. And then I'm going to subtract 21 altogether. When I plugged in -7, I got 77 for h of -7. On number 4, I'm going to plug in a 4 for x cubed. So I have k of 4 is 4 cubed minus 3 times 4 squared. 4 cubed is going to be 4 times 4 times 4. So that would be 64. 4 squared is 16. So minus 3 times 16. So that means that I have k of 4 equal to 64. This will give me minus 48. Putting those two together, I get 16. So k of 4 is 16. Over here, I'm going to plug in a -2 for x. So g of -2 equals -2. I have to square that and then add 5. Remember, negative 2 squared is negative 2 times negative 2, so that's positive 4. And then add that to 5, that'll give me 9. So g of negative 2 is 9. Next, we're going to evaluate the function f of x at these values. So we're going to plug in negative 4 first and foremost. We'll take f, we'll plug in negative 4. That means we're going to do 10 times negative 4 and then subtract a 4. 10 times negative 4 is negative 40 minus another 4. That'll give me negative 44. For the next one, we're going to take f and we're going to plug in 5. That means we'll take 10 times 5 and then minus 4. 10 times 5 gives me 50, minus 4 gives me 46. For the next one, we are going to, basically, this new notation is, I'm saying, hey, I plugged some number x in and I got a 6. What is the number that I must have plugged in? What number must I have plugged in? What was x so that my answer or this thing simplified to be 6? If you can't logic your way through that, the easiest way to do that is say, okay, well, my original function was f of x equals 10x minus 4. And I say right here that f of x is 6. So instead of writing f of x, write 6 and then solve this problem. Again, I'm just substituting f of x with what he equals, 6, and then I can solve the problem. We can add 4 over here on both sides, and then we have 10 equals 10x. Divide by 10 on both sides, and we have x equals 1. X must have equaled 1. If x equals 1, you can kind of check it. Well, if I plug in 1 up here, 10 times 1 is 10, minus 4, yeah, that is 6. We did do that right. For part D, you can do the same thing. My original problem was f of x equals 10x minus 4. Well, it says that f of x is 0, so I'll write 0 equals 10x minus 4, and I'll just solve. I'll add 4 to both sides, and then I'll divide that thing by 10, and I got x by itself. You can either say 4/10 here, or you can reduce this to 2/5. If you really want, you could also write that as a fraction, which would be the same as 0.4. It's your decision there. And then the last one, I think we could maybe logic our way through this. What number would x need to be so that whole thing is negative 34? Well, if the x was negative 3, then wouldn't this first term be negative 30? Because negative 3 times 10 is negative 30. And then if I subtract 4 from that, I'd have negative 34 like I want. So I think my x just has to be negative 3. If you can't logic your way through that, just go ahead and plug it in like we just did with these other two. Replace the f of x with negative 34, and then add the 4 over, divide by 10, and you will get negative 3. Okay? Next up, let's go ahead and combine these functions. We have the two functions f and g, and we are going to either add, subtract, multiply, or divide them. For a, we're going to form this new function called s of x. And the way that we do that is we take our function f and we add it to our function g. So my function f from the direction says x squared plus 2x plus 1. I literally just, instead of writing f of x, I wrote what he equaled. And then it says I need to add that to my g of x, which is x minus 3. Before I circle my final answer, I want to see if there's any common factors or any common terms that we can combine. I have an x squared. There are no other x squareds. Oh, but I have 2x plus 1 more x, so that's 3 x's if I put that together. And then here I have a 1 minus 3, so isn't that minus 2? So s of x altogether would be this simplified new function. For part B, we're going to take f and we're going to subtract g. So my new m of x is going to be formed by taking x squared plus 2x plus 1. Remember, that's just f of x from the directions. And then I need to subtract all of g of x. So I'm going to put subtract parenthesis x minus 3. Okay, make sure you distribute this parenthesis before you do any simplifying. So really this is x squared plus 2x plus 1 minus x, and then a minus minus becomes plus 3. To finally finish here, let's go ahead and combine like terms. I only have one x squared piece, but now I have 2x minus an x, so that's just 1x left over. And then I have 1 plus 3, so that's plus 4. Here's my new simplified version of that function m of x. For v, I'm going to take 2 and I'm going to times it by the function f, which is x squared plus 2x plus 1. Notice I am writing that in with parentheses. That will really help because then I realize that I need to distribute this 2 to hit every single term in that function f. That means I have 2x squared plus 2 times 2 is going to give me 4x, and 2 times 1 at the end is going to give me that 2. Last, for part D, d of x is going to be formed when I take g of x, which is x minus 3, and I subtract, again, parentheses here, x squared plus 2x plus 1. Let's go ahead and, again, just like we did on part B, distribute that negative and make sure everybody changes negative behind that parenthesis. So negative x squared, negative 2x, and negative 1. Combining like terms gives me just a negative x squared by itself, and then I have x minus 2x, so that's minus 1x, and then I have negative 3 minus 1, that's negative 4, which is equal to my new function d of x.